we should really start asking a question and get more precise. So our question should be, what is a radioactive decay? That's really what we got to answer. And that's going to take today and definitely on Thursday. And I wouldn't be surprised if we go on to Tuesday, but I'm hoping we could finish this by Thursday. So here we go. So let's give you just a little bit of background here. These three radiations, and this would be alpha, beta, gamma, were discovered by Rutherford himself. Can't misspell Rutherford's name. And he did this in 1900 before he discovered the nucleus. In fact, the reason that he discovered the nucleus is he was trying to understand more about the alpha particle. 2. Rutherford coined these names. Again, what are the names? Alpha, beta, gamma, by how much they penetrated a material. So the best way that I can do this is that I could draw a picture of it. So let's do that. So imagine that I have a sheet of paper. So here's my sheet of paper. So I'm going to shoot radiations at this sheet of paper. What you'll find here is that I'm shooting alpha. Then I'm going to shoot a beta. And then I'm going to shoot a gamma. So again, this is an alpha. This is a beta. And this is a gamma. And what happens here is that alpha is stopped by paper. So a sheet of paper will literally stop alpha. So then we go to the next thickness here. So if I go to the next thickness, what we do here is that we add several sheets of aluminum. So if you have thick aluminum sheets, what you find in this case, so again, this is several aluminum sheets, but they're thicker. There's the thick version. What you'll see here is that beta passes through that, through the paper, gamma passes through that, but beta is actually stopped by the aluminum. And then if you want to stop gamma, well, it turns out that these are the most energetic ones. You typically have to use lead. So they use lead bricks to stop gammas. So then you need lots of, not, I don't want to say lots, but you need lead bricks to stop gamma. So you could see here is that alpha penetrates the least, while gamma penetrates the most. So as you could probably guess, gamma radiation can be more dangerous and usually is more dangerous. So moving here, we then could come in and we could talk about what happens in a radioactive process here. So a radioactive decay is a process by which a nucleus spontaneously undergoes a change that emits energy. And when we say it emits energy, that really means it emits a radiation as particles. And it turns out that there are two kinds of processes. So here, what you find here is that the first process is that you literally change the type of element. You literally change the type of element. So alpha and beta result in the emission of radiation particles. From the nucleus. So when you look at these things, here's what you find. So the radiation particles, one of these is called an alpha particle. The other one is called a beta particle. That's what I mean by radiation particles. And what does this do? It changes the type of element. So it literally changes the atomic number. And remember, the atomic number is the number of protons, which then means that you change the identity of the atom. And then there's this other kind right here. So this other atom then goes like this here, is that I said 4, sorry about that, it should be 2. And in this case here is that there's there's no change in the type of element. And there's only one process that does this. Gamma decays release very high energy light waves. And what you find here is that when you look at this, these do not change the identity of the atom. And that's the two big classes right there.